Okay, we're going to look at number 17 in section 3.3. And at first glance, this seems like it's going to be a doozy. Calculate the derivative for this function, g of z. Oh my goodness, this times this, pretty complicated. The variable is z here. And they say to calculate it for z not equal to 1 and 5. Of course, it makes sense because the function's not defined at 5 or 1. Therefore, it's, of course, not continuous and not differentiable at those points. So the hint they give you is to simplify first, okay? And that's a very important hint. You do not want to go and just straight up say, okay, I've got a product, so let me use the product rule. And then when I take the derivative of each of these, they're quotients, I have to use the quotient rule. You're going to have a big mess if you try and just brute force this through with the product and quotient rules. So again, the idea is if you can simplify a function before taking the derivative, most of the time that's going to make life a lot easier. Now, how do we simplify? Well, I want you to recall, you should remember factoring the difference of squares. A squared minus b squared factors is a plus b times a minus b. So notice z squared minus 1 is z squared minus 1 squared. That's the difference of squares. I can factor that. Z squared minus 25, difference of squares. Z squared minus 5 squared. I can factor that. And that's what I do down here. Z squared minus 1 is z plus 1 times z minus 1. And notice this z minus 1 factor can now cancel with this z minus 1 factor down here in the denominator, because these two are just multiplying fractions together, right? The top of this second fraction, z plus 5 times z minus 5 is how that factors. And notice the z minus 5 factors disappear. So guess what? If I simplify it, it's just the product of the top two over what? 1. So it's just this, z plus 1 times z plus 5. And you say, well, use the product rule on this now to find the derivative. No, just go ahead and expand that out, FOIL it out, right? Z times z is z squared. The outer is 5z, inner is z, last is 5. Combine like terms. Just take the derivative of that. That's easy. Just use the linearity rules and the power rule, constant rule, and we get derivative z squared is 2z, derivative 6z is 6, and derivative 5 is 0, but there's our answer. Okay, if you try again, brute force this from the beginning, try to get to this answer, you're going to be spending a lot of time. So again, the thing is, if you can simplify, please do so, and you can get out of, notice I didn't use the product or quotient rule on this at all. Okay, hope this is helpful.